Okay.
Yeah, that's it.
Okay. Okay.
Yeah.
Right. So this is, as I've just said, observations of beta Lyrae brightness, 1997 to 98, which is when I did these observations. So basically, why it varies. Before I give you my results, I'll just go through the just a few words about beta Lyrae itself. This star, which is actually two stars, is the reason why it actually does vary in brightness, and not because of something change, increase or decrease in size or light or energy output. So the two stars are seen from either the top or the bottom will just appear to be orbiting around one another. But fortunately from Earth, we see this system edge on from our line of sight. So it's an eclipsing binary and doesn't sort of have it doesn't vary in brightness intrinsically. And I've just drawn a few pictures just to illustrate this. I will call the hello.
Yeah. Yeah.
Yeah.
Yeah.
I'll call the brighter component of this binary B, because it is a B-type star, also I believe, which shines with a surface temperature of around between 12 and 25,000 degrees centigrade. So it's a very hot blue star, and its companion star, which is fainter, is a white. It's an A-type white star that has a surface temperature of around 8 to 10,000 degrees centigrade. So they're both very hot, but one's more hotter and luminous than the other. So the methods that I used are from a book that I bought quite a long time ago, in 1998, called Observing Variable Stars by someone called David H. Levy of Schumacher-Levy, one of the guys that co-discovered the comet that eventually plunged Jupiter. It's called Observing Variable Stars, a Guide for the Beginner. And I used sort of hints from that book to do these estimates. The star itself is in the constellation of Lyra, as you would expect. And the book tells you to take two nearby comparator stars of no magnitude. In this case, Gamma and Zeta Lyrae. Gamma shines with a brightness of 3.24 magnitude, and Zeta 4.4. And Beta Lyrae, its sort of maximum brightness is 3.25 to 3.3, and its minimum is 4.3 to 4.4. So Levy sort of suggests that you use a visual score scheme similar to this one, which is the one that I've used, whereby you score it 1 if beta is as bright as gamma, 2 if it's slightly fainter and gives you this sort of range of magnitudes, 3 if it's halfway between the two, 4 if it's just slightly brighter than Zeta, and 5 if it's as faint as that star. And doing this, I ended up with this set of results. Now, as you can see, over 2 months from 1st of October 1997 to the 2nd of December, I only got 6 observations in, although there was obviously a certain amount of dimming and brightening going on, but I didn't know whether this meant anything, whether I was doing it correctly or not. Then there was a bit of a hiatus when I either lost interest or didn't do it for a long time because of the weather or for whatever reason. And then I picked it up again for around about the sort of beginning of July of 1998, a month between that and the next one, and then a sort of string of ones that I tried to put together that would be consecutive, but it just didn't work out that way. Quite often I'd look out the kitchen door when it got dark around about November time, and the clouds had just rolled in. There was nothing to see. And so again, I got about 8 observations between November and December 98. A couple in the following year in January of 99, and then a huge long gap, and then just this one last observation here. And these are all the magnitudes that I recorded. Now, I tried, I also used my naked eye visual estimations using the method I've just shown, but also I also used binoculars to help me when things were particularly hazy or the star was very dim. I had used originally a pair of 8x40 binoculars, and just recently I've taken up using the Zeiss ones that I sometimes take to the observation evenings at the New Inn. They're Zeiss Wetzlar field binoculars at 12x50. And I really didn't know what to do with these figures. Tried putting them onto some sort of graph with time along the x-axis, but I was just doing it linearly, and there seemed to be no pattern at all, so I more or less gave up on that. But then I hit upon the idea of putting it the sort of minima and maxima brightnesses on just a word scattered diagram, and that's what I did. And then traced these are the maxima and minima ones are the ones I've just traced out here that are in sort of orangey red. My data is in are the blue dots, and this first part of the graph shows a period of 12.9 days, which is how long it takes for the beta Lyrae to increase in brightness to its maximum, then dive to one of its minima, the one where the brighter star eclipses the fainter star. It then moves away from the fainter star, so both become visible again, climbs up to maximum, and then over the next sort of 6.5 days, plunges back down to its secondary minimum when the fainter star hides the brighter star. At this one, you're getting sort of 75% of the light that you would get coming from it at maximum, and down here you're getting 50%. And it does this over a repetitively over a cycle of 12.9 days. So what I did was I put one cycle on this graph and put in the first dot, first blue dot or the first piece of data where I thought it might go on this. And I just had to use trial and error to find out which worked, because I could put the first datum, say, I think it might be that one, could put it there and see what happened over the period of 12.9 days and beyond as you track from the first data point. And it didn't work when I put it there, didn't work when I put it there or there. But when I put it there, I got this pattern, which, although is I the first to admit, is not really perfect at all. In fact, I'd probably, if I had more time, enhance and sort of make this graph better. But in the time I had available, this is what I did, and the data does kind of fit. You've got sort of climbing up from there over time to there, although it's as I say, it's not perfect, and then dips down, and then climbs again. Then I've got 2 points that are more or less superimposed on one another there, and then it starts going down, although I got no estimates down in this region at all with the 1997 data. With the 1998 data, I decided to first of all try and superimpose it on this one sort of 12.9 phase of this light curve. But when I did, it was all over the place. It just looked like complete random static. And I wondered whether I'd got it out of phase somehow, or whether I'd lost track of the days, because there was a huge amount of days, something like 260 between this set of data and the next, the 1998 stuff. So I just plotted that on a replica of the first 12.9 day phase, and again I got some sort of semblance of a wave. Oops, sorry, gone off. How do I get back on again?
Need to share your screen again. Go back to your PowerPoint. Yep.
I did get some correlation right down here, although again it's not perfect by any means, and I'm not sort of pretending that this is really great, but I was quite pleased that it did actually seem to show some periodicity. And I've just put on inset here a graph of the beta Lyrae light curve for comparison that I got off the internet. And this is the kind of it's the classic. The beta Lyrae one is the archetypal eclipsing binary light curve. I don't know. I hope you'll agree that I've got something there, but it needs more data and more refinement. And that's all I want to say about that at the minute.
Very much, Andy. I think that's absolutely fantastic.
Now, before anybody else says or asks anything, I've looked at the data in this. I'm quite amazed that it's sort of worked out that way, because I had no idea when I was doing it how it would pan out if I put it on a graph. And it's just entries from a book that an observation book that I've got, one of these old sort of exercise books. And I've also got data that I did using the same method for beta Perseus. Is that Algol? and I've tried it with R and P Cygni, which are stars that are suggested by Levy in his book. So I'm going to hopefully at some point sort of look back and do something similar with that data and see what I come up with, and maybe some material for a future informal presentation. So that's it from me.
Very good.
I thought the degree of agreement with that little graph that you've had in set was incredible. Showing
Well, I was amazed by it because it took me ages to get it to look like that, and it sounds a bit like cheating, but all the data follows on from one another in an order that is recorded. So it's just a matter of knowing where to put the data point to start with. I had to do sort of simulations and see how they panned out about 4 times with the starting datum on the 1st of October. And that was when I eventually came up with that.
In the time that you've been taking measurements, you seem to have caught about 2 cycles.
Well, no, because there's lots and lots of cycles. It's 12.9 days long, and then it
I appreciate that,
over again. But I've not. You see, the problem I had is that I didn't have enough data points to get a smooth kind of twin peak graph. They're all sort of. There's loads of. Nearly all of them. There was 3 or 4, 5, usually 6, or even longer days between each observation, which is a bit annoying, and it's probably one of the reasons why I gave up in the end, because otherwise, it's just somehow, I'm never going to get that kind of continuity of data. But then it suddenly struck me that you could just, as long as you knew how many days had passed between the last data point that you put in, you could just use the same graph and put it in again.
Yes,
and that's when it started making sense to me.
I get how you put the points onto the graph, but now you've done it and you look at that graph, I'm seeing about 2 cycles, 2 and a bit cycles, and I'm just wondering if you might like to cut it in half and superimpose the second cycle on top of the first, and you might see an even greater smoothness.
Yeah. I say that's something I'm thinking of. I'm definitely going to be playing around with when I've got lots of spare time, which I don't actually have.
It'd be lovely if you could post your results graph on the chat line. I'd love to look at those dots again sometime.
Yeah, I'll do that when I played around with it a bit more. I might even have something for who knows, for Algol, for Beta Perseus. And from what I've read and seen, which isn't a fantastic amount, because as I say, I've only just started becoming interested in this again. That 12.9 day cycle is actually slowing, they reckon, by about 2 minutes per year. And there's also some periodically some strange spurious magnitude data comes out of each cycle, which they quite often they're struggling to explain. So it's still quite an interesting variable star to look at, even though it's not actually physically changing in terms of its the 2 components are just stable magnitudes that together orbiting around one another.
I'd have thought that if they're so near to go around each other in a couple of weeks or whatever, you'd have thought they'd be getting nearer to each other and speeding up.
Speeding up? No, it appears not to be the case. I know that one of them I think the brighter one is actually accreting an enormous disk of hydrogen gas, hydrogen and helium around it from the fainter star. You know, there's material being drawn off from one to the other, but the whole the whole binary system itself is also coated, that's enshrouded in an enormous disk of gas as well. So
Very
things are
interesting.
changing. Yeah.
The other thing that occurred to me, sorry to keep hogging the limelight, but it's a perfect setup for someone starting out in variable star observations, because you've got the two limits right near to the variable star itself in the constellation.
Yeah.
It's incredible. I've just, whilst you were talking, I got Stellarium going, and I found that something like 135 millimeter telephoto lens would very nicely get that little trapezium of stars of Lyra without catching Vega itself. And it would be quite an easy thing then to just take lots of photos every time that the night is clear. And it doesn't matter about the quality of the night, because it'll affect all 4 stars in the constellation. So you've still got a good comparison.
If you want
Well,
to
yeah,
do
that's
things,
something to consider.
if you want to do things the easy way, you can get predictions of the maximum and minimum in the magazines, I believe, and doubtless on the internet. I think they're in Sky and Telescope. So
Yes, yeah.
an easy start. Yeah, it would be a very good photographic project, as you say. You could maybe even, make a little GIF animation out of it if you're clever enough.
Yeah.
I'm
No.
too bone idle personally, but yeah, why not? And one possibility I thought for this increase of orbital period. I mean, as you say, there are various possibilities, but maybe it's a sort of Earth-Moon situation. You know, as the moon's orbit has widened, as its rotation has become synchronized with that of the Earth. You know, it's a synchronous situation now, and the moon will eventually be even further away. The two planets will be constantly locked with the same faces facing each other. I don't know whether that works for stars, to be honest, but it's a possibility that their gravitational influence is, as it were, slowing down each other's rotation, and that energy is going into angular momentum and hence separating the stars. Just a thought.
Possibly, yeah. I don't know.
Yeah.
I'll have to start boning up on this particular system a bit more than I have.
What?
As I say,
What if you?
pardon?
Sorry, butted in. What if you did a log of each reading? What if you took a log of each reading? Would you get a better curve? Did it logarithmically? A logarithmic. You know all the data you took. If you did a
Yeah.
log off each one, would you get a better curve?
I don't know.
I mean, it's quite interesting.
Yeah.
Just a thought. Just a thought.
Maybe I could try that. Yeah.
Okay. Well, does anyone else have any comments or questions for Andy? Okay.